Hey guys, hey, welcome back. Welcome back to the most recent installment of Learning Math with Mr. Bauman from Mr. Bauman's Basement. Hey, we got, I hope, an exciting lesson for you here today. I haven't seen you in about a week, y'all, and got a little bit different background for you. Got some new records here behind us. New to you, not new to us, but foosball table. Some pretty intense foosball games happen right behind us here. But right around yonder. But the most exciting addition to this installment of Learning Math with Mr. Bauman from Mr. Bauman's Basement is the one and only Miss Betsy Bauman. Welcome to the studio.
Hi.
Y'all.
Y'all.
I feel like with these hats, like we should say y'all more, or what's something else, like people from the old West. They what else do they have besides the nice cowboy hats, y'all? They have. What's the name of your horse that you just rode in on?
I don't know.
You don't. Everyone has a name for their horse. What's the name of your horse?
I don't know. What's yours?
My horse's name? Goldie. That's right. Ma'am. Just rode in on my steed. Is that what they call? I think that's what they call horses. Your steed, your trusty steed, and I got him tied up yonder, and he's just getting a cool drink of water in the trough. So what's the name of your horse?
I don't know.
If you had a horse, what would be the name of your horse?
I don't know.
Nothing?
I don't know.
Every time Lily walks by, Lily's the camera woman. Every time I walk by, it's thank you, ma'am, running the camera. What would be the name of your horse?
I don't know.
The audience is waiting. All of the subscribers.
There's only like 3.
All one of them?
I don't know.
No? How about I ask you at the end, so you have some time to think about it?
Oh, and when we rode horses, my horse name was Nugget.
Oh, when we
Nugget.
actually rode horses last summer? Yeah. Out in the Rocky
I
Mountains?
think it was Nugget.
I think it was.
I think mine was strawberry.
Strawberry.
Strawberry?
Speaking of strawberry, this is about the reddest shirts that I've ever seen in one screen before. How about that? Good gravy. That's some red shirts right there. But gosh, yeah, I feel like we just came in from the old West. I got the mustache going. That looks very like old West. And if only we had like a beard. I can't grow a beard very well. Could you grow a beard?
Maybe.
Let's try it. That's pretty good. Let me see if you had to smile with the beard. Let's see if we can see your mouth through the beard. Do it. You can do it. You can do it.
I have to get my mouth though.
That's pretty good. That's pretty good. That's a good life skill. Are you ready to do some math today?
I guess.
This is getting into some 8th grade algebra. Are you ready for the challenge?
No.
Yes, you are. I mean, anybody rocking the cowboy hat, ma'am, is ready for some good old-fashioned algebra. You ready? Let's do it.
Ow.
Foosball tables. Where you going, camera woman?
Sorry.
You taking off? Oh no, we spilled water on the whiteboard. How'd that happen?
There's no water.
Maybe it's
over
sweat.
here.
Maybe. Are you nervous? Did you sweat on this board?
No.
Hey, here's the y'all. Here's the title and the objective. We got some exciting 8th grade algebra planned here today. We, Betsy Bauman, are going to be looking at lines in slope-intercept form, and we're going to find out where they cross. Kind of like the path of 2 horses sometimes cross. The path of our lines are sometimes going to cross. And we're going to figure out where that point of intersection happens to be. So our objective for today, use slope-intercept form to graph 2 lines, and we're going to figure out where those two lines and when do those two lines intersect. All right? That's some exciting, gosh, I got to dry off this board here. You hold that one. Let's hope the magical eraser works. So I got all my needed supplies. It's good enough. Good enough. We got the whiteboard, obviously. We got the magical eraser. Each of us got our marker, right? Ready to go?
Yes.
Got our cowboy hats. Ma'am. And of course, no good math lesson is complete without some relatively lukewarm black coffee.
Ew.
Except my partner here, she's got some,
Water.
used to be ice water, but now it's just water. You ready? See if you can do this. Swoop in. Cheers. Dink. Come back. Take a sip. And then swoop in. That's good. That's pretty good. I'd give that a like a solid B plus. That's pretty good for your first crack at it. You ready for this? Do you smell that? You know what it smells like? It smells like my horse. It smells like an amazing lesson. Point of intersection is what we're going to find here today. We're going to cross two lines. Sometimes they might be doing this. One of them Gunther might be having a positive slope. One of them, Gunther, might be having a negative slope, so they have to cross. Sometimes they both might have a positive slope, but one is rising faster than the other. And that's what's going to happen today in our lesson. But before we get to that, let's kind of take a walk down memory lane. Walk down memory lane to last week's lesson. We were looking at actually three individuals with water bottles. Remember this one? And we're going to look at two individuals today. We're going to take a look at Walt and Donald. Now, if you recall, Walt, last Tuesday on your assignment, thank you, ma'am.
Welcome.
Ma'am. Good gravy. Walt was filling his water bottle, and he was filling it at a drinking fountain, and 1.5 ounces per second were being added to his water bottle. And his water bottle started at 3 ounces. So you guys came up with an equation that looks like this. This is in slope-intercept form. Just to remind you very quickly, slope-intercept form looks like that. Y is equal to mx plus b. We all know from 7th grade that m represents the slope. B, you just learned it last week, that's the y-intercept. That's where the line starts, or where it crosses the y-axis. So let's look at Walt. Walt's y-intercept is 3. That's where it crossed the y-axis. This should look like your homework from last week. And it was rising at 1.5 ounces per second. Let me pull that in a little bit. That's what your graph last week should have looked like. Then we looked at old Donald. Donald was goofing. Oh, gosh. Was goofing around. Is that all right?
Yeah.
Yeah. He was goofing around, and he spilled his water. His bottle was full, so he had 15 ounces in his water bottle, but he spilled it. And water was dumping out really pretty quickly. It was dumping out at 3 ounces per second. So his slope was negative. So his line started at 15. That's pretty good. Started at 15, but his was dropping at a much faster rate. So I went ahead and started Donald's graph here. So his was dumping out at 3 ounces per second. So it should have completely emptied in 5 seconds. So Walt had a positive slope. I'll put a capital W. Oh, it's already there. Capital W for Walt. Donald's line is the one where Gunther is going downhill. So Betsy, what do these two lines have to do?
Cross.
They have to cross. What's kind of like the big algebra word for cross?
Intersect.
That's very good, Bets. Very good. Gosh, 5th grade math.
You definitely didn't just tell me that behind the whiteboard.
Hats off to Mrs. Cadigan for the bright young lady here just rolled into town on her horse. Who knows some good algebra terms there? So these two lines have to intersect. This point right here is what we're really looking for today. So we know, according to our graph, that at some point between 2 and 3 seconds, Walt and Donald had exactly the same amount of water in their bottle. It only happened instantaneously, and after that point, Walt had more than Donald. Donald started with more than Walt, but as these lines started to move across the x-axis, they crossed, and at that point the opposite was true. Walt had more water than Donald here towards the end of this graph. That's analyzing the graph, but today we're focused right on this point right here. We're looking for this x comma y, which we call the point of intersection. And when you get to 8th grade, in just a few short weeks, few short months I should say, but in just a few short weeks you won't be 7th graders anymore, you'll officially be 8th graders. We call this point of intersection POI, or as I like to refer to it, POI. You have to say it kind of like high pitched like that, even though I'm just rolled in on my trusty steed.
Stop.
We're going to call it the POI, the point of intersection, or the
Poi.
Very good, young lady. All right, are you ready to do this? Now we're not going to do Walt and Donald because we did that one last week. Let's look at our own real life example. Let's suppose, you want this board, Beth? So you can do your own graph as I do my graph? How about that? All right. So let's suppose, and I would say this is fairly true, and you tell me if you agree, Beth. By the way, do you like this so far? You enjoy this math lesson? It's a little strange being down in the basement and learning math.
Yeah.
Yeah. What are we normally doing down here? I asked your sister the same question last week. What's a normal, like, hey, let's go downstairs, Bets. What do you want to do?
Play pool.
Play pool. That's good. You're getting really pretty good at it. Yeah. What else is a common activity down here?
Work on the puzzle.
That's a good one. Work on the puzzle. Yeah. One thing we've never done down here, little lady, is run a race. You want to run like a virtual race today?
Sure.
Yeah, okay. Let's do it. So if we were actually running outside, running a race, who would win between you and me?
Me.
Ooh, that was a quick answer. Now, like us running, not on our horse, but like us actually running, you say you would win.
Yeah.
All right. Well, let's try it out. Let's look at the math behind it and see if that's actually true or not. You want to do that?
Yeah.
You think your hat would slow you down?
No.
I think mine would. I think the wind resistance here would be quite substantial. I mean, this sucker. Do you remember getting these?
Kind of.
You remember where we were when we got these cowboy hats?
It says in here. No, it doesn't. Texas somewhere.
Texas. We're in Fort Worth, Texas. Yeehaw! Good gravy. All right, so let's pretend that Betsy and I are going to run a race. All right? We're going to run a race. And even though I'm a bit taller, Betsy's getting pretty tall nowadays. Do you think the fact that I'm taller would make me faster?
No.
No? Do you think the fact that I'm like 30 years older than you, do you think that would make a difference? Or roughly 30 years older. Do you think that would make a difference?
No.
No, you think that by default makes you faster?
Yes.
Because an old man can't run that fast, right? All right. So let's throw some numbers out here. Let's suppose our race.
Can I write this?
Yeah, please. Actually, no. When we get to the graph, these guys at home, if they're still watching, they're like, if he says "good gravy" one more time, I'm turning this off. Good gravy. Let's suppose the race is 90 feet long. So we go outside. I'm like, Betsy, see that oak tree over there, over yonder? Let's run to the oak tree, okay? And that's 90 feet away. So our race, 90 feet long. Okay? Let's suppose that Betsy runs, let's go 15 feet per second. Kind of abbreviated it there for you. Betsy runs 15 feet per 1 second. That means literally every second that goes by, how far do you go?
15 feet.
Perfect. All right?
That's a lot.
Yeah, but you're so fast, though. I mean, you're like, people can't even see you go by. It's just like this flash. It's like this red and like brown flash that goes by when you run. Like you're flowing locks of hair. That's all they can see. It's just like this flash of light. So we're gonna call me Dad today, only because I think it would be weird for Betsy to keep calling me Mr. Bauman. Do you agree?
Yes.
So let's suppose Dad, the old guy, is slower. So my rate should be lower. This is actually technically our slopes. Betsy's slope, I could have just as easily put the letter M for her. Betsy's slope was 15. Mine's only 10. My slope is 10 feet per second. Okay, get those down in your notes. It's going to be important for our graph here over the next few minutes. Okay, I'm slower because my slope is lower. Betsy's faster because her slope is higher. Are we good so far? Mm-hmm. Okay, so if we both started at the same point and my wife said, all right, on your mark, get set, go. And poof, like we both started running, act like you're running. Who's going to be in the lead?
Me.
Yeah, because you're faster, right? Who should win?
Me.
You, right? Because you're faster. But Betsy is so kind. I mean, look at that face. I mean, it just screams kindness, right? She's like, gosh, Dad. She's thinking to herself, you're kind of old. You're kind of slow.
Yeah.
That hat is like and it's gonna like slow you down. It's like a big old sail that's just gonna catch too much wind. It's gonna slow you down. Dad, I feel kind of bad for you. So, what do you suppose a really kind person would do? That if you're the faster one, and this guy's kind of slow, and you know we're gonna race 90 feet, and you know you're gonna win because you're much faster than I am. What's one thing you could do out of the kindness of your heart? What could you do?
I could give you a head start.
Ooh, that's a good one. All right, so let's do that. Let's suppose Betsy gives me a head start. Let's go 20 feet. Do you think that's good? A 20-foot head start. All right, thanks, Bats. I'd give you a kiss, but I can't reach your head. The hat's in the way. All right. So Betsy gives Dad a 20-foot head start, which literally means Betsy's still at the start line. And I'm 20 feet ahead of her, even before my wife says, on your mark, get set, go. All right? So, boom, as soon as Mom says go, who's winning?
You.
Right. About by how much? Roughly.
20 feet.
20 feet, right? 20 feet. But as time goes on, what's going to start to happen?
I'm going to go ahead of you.
Yeah, you're going to catch up to me and then probably go ahead of me. So at some point, if you start to catch up and then take the lead away from me, at some point, boom, like at some instant in time, we should be what?
Tied.
That's right, we should be tied. So it's, act like we're running. There should be one point where I look over and I see Betsy. No. And then you would be ahead of me at that point. Does that make sense?
Yes.
Is that a pretty good slow-mo?
Yes.
Yeah. Let me hear yours.
What do I say?
And then you'd be like, I'm gonna beat you. Okay, ready? No. And you say,
I'm gonna beat you.
That's pretty good. All right. So let's graph it, okay? So let's graph it, and let's also try to come up with the equation for each of us. All right. Let me find my notes here. All right. You already started your graph. Look at you. All right. So you guys, if you have graph paper, go and pause the video. Go find your graph paper. If not, you can just do this right in your notebook. You only need the first quadrant. Have you guys talked about quadrants yet? No, not yet. You'll get there. You'll get there. How about, Bets, how about this axis right here? What letter do we call this one?
X.
X, very good. The vertical one, so like the up and down one?
Y.
It's the Y, very good. So let's measure seconds on the X. So we'll just put SEC for seconds. And over on the Y-axis, we're going to measure that as feet. So we just put FT. All right, so if you have graph paper, great, good for you. If you don't, with a straight edge, and I know something in at your house is straight, like the side of your notebook, maybe you have a ruler, whatever. Make an X and a Y axis, and let's go up. If the race is 90 feet long, right, we need at least, let's skip count by 10. So we need at least how many little marks here, Beth?
9.
9. Okay, very good. Try to space them out evenly.
I didn't.
That's PDC. Do you know what that stands for?
Pretty darn close.
That's right. Very good. Make mine a little bit taller. There we go. And then again, skip count. So I'm labeling my units. You go ahead and do yours. That's if you want to show them yours, so they have something to model off of. Thank you. Yeah, you can go ahead and put it down. And let's go out let's go out about 7 on the x-axis. So again, try to space them out evenly. Try to space them out evenly. I just accidentally erased part of it. Alright, feeling good with this? Alright, I'm trying to model this lesson here on this YouTube video very similar, kind of mirroring it off of what you're going to see in the Google Doc this evening. It's not the exact same problem, but very similar. So one of the first questions you're going to see, so I'm just calling this example 1. Let's come up with the equations. Before we start graphing it, let's see if we can come up with equations in slope-intercept form. So this is what you just learned in your video last week. So I want equations, I want 2 equations. One of them is going to be for Betsy. One of them is going to be for me. All right? So y is equal to mx plus b. Here's the slope. Here's the y-intercept. We know that x represents what? The x-axis represents what?
Seconds.
Seconds, good. And the y represents what, Bets?
The feet.
The feet. Very good. All right. So let's call the first one Betsy. So Betsy's equation.
Can I write this?
Yeah, just up here in this corner, so you can kind of refer to it. Welcome to 8th grade algebra. So what was Betsy's slope? We talked about it a few minutes ago. What was your slope?
15 feet.
15 feet, good. So it's 15x. Now, did Betsy get a head start? True or false, Bets? Did you get a head start?
No.
No. So when you start the race, how many feet into the race have you gone? When Mom says, go! At that moment in time, you are how many feet away from the start line?
0.
0, that's right, because you're on the start line, right? So her equation is going to look something like this. Y is equal to 15x plus 0. Now, do you have to put the plus 0? No. In fact, I'd prefer you not. It's only kind of complicating, not complicating, but it's an unnecessary step. And we're going to get to a point where we're trying to cut out the unnecessary steps. So Betsy's equation, in slope-intercept form, would look like this. Y is equal to 15x. All right? So let's do Dad. My slope, Bets, bigger or smaller than yours?
Small.
Smaller. What number was my slope? My speed?
10.
10. That's right. 10 feet her 1 second. Now, where should my line cross the y-axis? In other words, in real life, when Mom says, on your mark, get set, go! How far into the race am I already completed? Have I already completed?
20.
20, very good. So my B, my y-intercept is 20. Because Betsy, because she's so incredibly kind, she gave me a 20-foot head start. So once we have these two equations, this is exactly what we did last week in last week's YouTube video that you practiced with the water bottle example. Let's start by graphing Betsy. Okay? Her y-intercept, Betsy just mentioned a couple minutes ago, it's 0. That land on your toe?
No.
No. Betsy's y-intercept is 0. In other words, she starts at the origin. How quickly is Gunther climbing here? Every second that goes by, Betsy, how many feet have you gone?
15.
15, that's right. So after 1 second, you'll be at 15 feet. 2 seconds, how far will you be?
30.
30, good. 3 seconds, how far will you be?
45.
45, good. In other words, we're skip counting by how much?
30.
Try again.
15.
15, there you go. 4 seconds, 60. I need a little bit of space, so I'm going to have to erase my equation, sorry. Do you need to too?
Yeah.
I'm just out of space. Where are we at? 5 seconds? 5 seconds, so 15 on top of 60 is how much?
75.
Good. Have you finished the race yet?
No.
No, but your PDC. How about on the 6th second? What's 75 plus 15?
90.
Very good. So you should have, all of you, including Betsy, should have a line that looks something like that. It's a really pretty steep line, which kind of makes sense. Why is her line so steep? Why, Beth? Why do you suppose your line is so steep, relatively steep? Because you are a blank runner.
Fast.
Fast runner, that's right. Now, should my line, Bets, which we haven't graphed yet, but should my line be steeper than yours, do you think? I know you're not in 7th grade, but from what you've learned so far, or should my line be not as steep? In other words, like more shallow.
Not as steep.
Not as steep, very good. Why?
Because you start at 20, and if I start at 0, then it goes up higher.
True, but what kind of runner am I compared to you?
Slow.
Slower, so I shouldn't be as fast as you, right? My line shouldn't be as steep as yours, right? So, but she brought up a good point. Where is my line going to start?
20.
20. Very good. So on the y-axis, as she mentioned, mine starts higher. So when my wife says, on your mark, get set, go! At the very start of the race, who's winning?
You.
Boom, this guy. By how many feet?
20.
20 feet, all right? 1 second goes by.
30.
I'm at 30, very good. Who's winning now?
You.
This guy. That's right. 1 more second goes by. Where am I?
40.
Where were you after 2 seconds?
30.
30. Who's winning?
You.
This guy. That's right. But not by much, right?
No.
Now, 3 seconds into the race, where am I?
50.
50. Where were you after 3 seconds?
45.
45. Who's winning? This guy, right? This guy. But barely. Barely. 4 seconds, where am I?
60.
60. Good. Good gravy. Good gravy. What happened?
I'm winning.
Nope.
No, we're tied.
We're tied. Very good. We're tied. Because we hit a point that we've already drawn, right?
Mm-hmm.
That's a common point. That's going to be our point of intersection, our POI, commonly referred to as
What are you saying? What?
POI.
Whee!
That's right. Very good. All right. Where are we at? 5 seconds. Where am I?
70.
70. Good. 6 seconds.
80.
80. Where were you at 6 seconds?
90.
90. You're like standing on the finish line saying, "Come on, old man, bring it. I thought you said you were going to beat me." So who won the race?
Me.
Very good. And then where are we at? 7 seconds. This little guy finally reaches what?
90.
90. So if we draw, I'll go ahead and hold mine up.
Oh, mine, I didn't.
You're fine. You're fine. So, let me label these. This one is Betsy. We'll call it B for Betsy and D for Dad. So you should have a graph that looks something like this. Betsy's was much steeper because she was faster. Good. This old guy's was more shallow because I was slower. Because our slopes are different, they have to cross. Our job today is to figure out where did they cross, called the POI or the...
Whee!
That's right. Very good. All right. So let's label this point. This is actually one of the... I'm kind of jumping the gun a little. Ooh. No pun intended. Jumping the gun a little bit. That's right, partner. So example number 2 in your notes. Where and when were we tied? So I'm just going to abbreviate the question. Where or when were we tied? So we're running. I was winning, and as time goes on, what starts to happen to the distance between the two of us? It shrinks, right? And at one point in time, I look over, I'm like, no, Betsy. And you're like,
I'm gonna beat you.
yeah, you're like, eat my dust, old man. Because at this point right here, which is an ordered pair, x comma y, we were tied, which was how many seconds?
4,60.
Perfect, young lady, 4,60. Very good. So at this point right here, 4,60, we're exactly the same, boy. 4 represents what? Seconds or feet?
Seconds.
Seconds, good. 60 represents seconds or feet?
Feet.
Feet, very good. So let's label that. That's at 4 seconds, 60 feet, we were tied. That's another question on your Google Doc. Again, not the same exact problem, but very, very similar. All right, we good on that? If at any point you do have questions, what should you do?
Am I supposed to answer that?
What could they do?
Email you?
Very good, they could email me. If this is back in the Old West, what would they have done?
Rode their horse to you?
The Pony Express. They get on the horse and send a message.
Mailed a letter?
Yeah, I don't know at what point like the postal service became a thing, but
Could have walked to your house.
yeah,
Could walk.
yeah. Milk the cows. What else did they do back in the Old West? Feed the chickens,
Yeah.
plow the fields,
Yeah.
churn the butter.
Yeah.
Yeah, this is like the
Pioneer Day.
like Pioneer Day. Yeah, yeah. All right, example 3. Which Betsy actually kind of already answered a few minutes ago, but now that we have a complete graph, let's answer example 3. Who won? Who won? And kind of part
Wan?
what?
It looks like Wan.
Wan. Who won? And part 2 of that question, by how many seconds? So Betsy, I'm going to throw the question at you.
Oh, I know.
Let's look at the graph, okay? I'm going to hold it up here. So can you see it if I hold it up here?
Yeah.
Okay. So this is your line. You had the steeper line. Mine's the more shallow line. So the question is, who won? Explain to me. Don't just say the name of the person that won, but explain to me how you knew that that person won. Who won?
Me?
You, okay. How do you know that you won? Just by looking at the graph.
Because when I was, my,
When you,
Oh,
how
my-
long was the race?
7 seconds? No.
How many feet? Let me rephrase the question.
90 feet.
90 feet, okay. Who hit 90 first? Look at the graph. Who hit 90 first?
Me.
You. And how many seconds did it take you to hit 90?
6.
6, good. How many seconds did it take for me to hit 90?
7.
7. So who won the race and why?
I won the race because when I was at 90 feet, you were still at 80.
Very good. Yeah. When you were standing on the finish line, like talking a little trash, saying, "Come on, I thought you said you were going to win, old man," I was still at 80. Very good. So you finished in less seconds. Very good. How many fewer seconds did it take you?
1.
1. Very good. You won by 1 second. That was the question to this, or the answer to this question. All right. Gosh, we are moving right along. We're going through these about as fast as Betsy won this race. How about that? So if we want to kind of put this like graphically or symbolically, Betsy's winning ordered pair would be 6, 90. What would that ordered pair mean, Beth? 6, 90. This is 6 seconds
and 90 feet.
90 feet. Dad, on the other hand, my
7,
order.
90.
Perfect. Yeah,
I read
mine.
the paper.
Do what?
I read the paper.
Oh, mine would be 7, 90. So I still finished the race. It just took me 1 extra second to get there, and you can refer to the graph to see that. There's Betsy's. There's mine. All right. Interesting question here. Let me kind of clean this up a little bit. I always love those like what if questions. What if a cowboy or cowgirl didn't have a horse? What would happen?
Run or walk?
Yeah, you'd have to walk or run. Good gravy. That would take forever to like walk to the Old West. Good thing we have horses,
Or cars.
which have horsepower. Oh, how about that? What was I? Oh, the what if question. What if, question number 6, on my paper it's question number 6. I've kind of lost track what question we're on. So, next question. Who would have won the race? Who won if the race, and just by looking at your graph, I want you to answer this. And you can look at your graph, you can look at my graph, whatever. Who would have won the race if the race was only, let's go 40 feet long? You know?
Yeah.
You got to be able to justify or explain how you knew that. Okay, let me get the question up for everyone at home. Who won the race if the race was only 40 feet long? And how do you know that, Beth? Okay, go ahead.
You would have won because at 40 seconds, if you like draw like a line over, you were ahead of me.
Yeah, close. One word you said at 40 seconds.
Feet.
40 feet. There you go. So, yeah, very good. So she finds it helpful to draw this like little line. I wish I had a different color marker, but I don't. So she said draw a line over from 40 feet. Who hits first? What line does it hit first?
Yours?
Mine. Very good. So I was winning, and according to the graph, the difference between you and I was how many feet? When I was at 40,
10.
yeah, you were only at 30. So I beat you by how many feet?
10.
10. If the race was only 40 feet long, right? All right, very good. All right, last question. So good for you. The race was 90 and not 40. If it was 40, this guy would have won. What if? Who would have won? If, again, it's kind of what if. Who would have won if the race was 60 feet long? So if we were like, hey, you know what? I don't want to go to the oak tree at 90 feet. You still gave me a head start. I only want to go to that like apple tree over there at 60 feet. I'm hungry. I want to stop and get an apple. Okay? Let's only do a 60-foot race. Clean it up a little bit. According to our graph, who would have won, Betsy, if the race was only 60 feet long?
You would have won. No. Wait, no, we would have tied.
Very good. We would have tied. How do you know that? Just by looking at this graph.
Because the lines intersect.
Very good. It's called the POI or the...
Boy!
Very good. All right.
Why do you put your hat up when I say that?
Because that's like cowboys, when they get excited, they hold their hat up. I think. I need to learn how to like throw it.
Like, what's
Like
his
jet and cord.
name? Yeah.
Good gravy. Or like learn to use a lasso. Wouldn't that be amazing? That would be a good life skill. What's another good life skill? How to beat your dad in horse. Ooh, speaking of horse, look at that for a segue. All right, very good. You're like a wealth of knowledge. You're like this well.
Well, we already learned graphs and
So you're using what you learned in 5th grade to help you with algebra?
like the y and the x and the comma with the comma.
Ordered pairs?
Yeah.
Yeah, this is like a commercial for like advertising the importance of 5th grade math, boys and girls, is what she just said. Algebra uses 5th and 6th grade math. Again, hats off to Mrs. Cadigan and all those other younger grade teachers that shape young minds like Miss Betsy Bauman so that they are successful in 8th grade algebra, finding the point of intersection or the...
Poi!
That's right, all right. Now, you want to see something really cool? I mean, everything we've done so far is like super off the chart cool, but let me finish with this like knock your socks off. If you're wearing socks right now that you're learning from home, you don't have to have uniform socks on. But this one's going to knock your socks off if you happen to have socks on. We want to know, the last question was, when did we tie? And Betsy said that it should happen at 60 feet, right? 60 feet, and it was how many seconds?
4.
4 seconds, right? So that's what we got graphically. Now, you're going to learn next year in 8th grade that graphing is great. It just tells you a good picture, but sometimes it takes a little time. And sometimes you just don't have the time to graph, right? So let me show you real quick. I'm talking like 2 minutes or less. Hang with me. We're almost done. Let me show you a little shortcut. This is like full-on algebra, straight on at you, algebra. If I want to know when we tie, that means as we're running down the path, I look over, no, and Betsy's like, yeah, eat my dust. And we're tied. That means we are equal. So what if I took Betsy's equation, which was y is equal to, you were 15x plus 0, right?
Yeah.
And Dad's equation, which was y is equal to 10x plus 20. So a tie means we're literally equal. What if I took our two equations, so I took this one and set it equal to that one? You ready for this? Hold on to your socks. They're about ready to fly off your feet, okay? What if I took Betsy's and I set it equal to Dad's? So I literally took Betsy's equation, set it equal to mine. You ready for this?
Maybe.
You don't have socks on, so it's not going to knock your socks off. Let's solve this. This is what we did in 7th grade. Let's solve this. We set the two equations equal to each other. Take away 10x from both sides. If you take away 10x from the right side, you got to take away from the left side, because you're learning 7th grade, Beth, that this is called the teeter-totter effect. You can't teeter without tottering. That sounds like a cowboy name. Totter. That could be the name of your horse. How about you name your horse Totter?
Okay.
Yeah. And it's
Like
it's
tater tots.
like tater tots. Maybe you could just call it Tot. How about that? Tots are amazing. I like tots. You like tots?
Yes, especially like the ones in like Disney. They're so good.
Yeah, they were good. Yeah, like cheese and like chili on it.
Yeah.
That was really good. Anyways, let's come back to our equation. So we teetered and tottered, and we got 5x equals 20. Just like that. We got to undo this multiplication that's technically between the 5 and the x. The only way to undo multiplication is to...
Divide.
Very good. Wow, you are on fire.
Ouch.
Yeah. And we... Oh my gosh. We got x is equal to 4, which is exactly what our graph told us. Good gravy. Good gravy. That's better than gravy, and gravy's really pretty good on anything. We got the same answer. Now, you ready for this? What if you took our x, because that's what the value of 4 is x. What if we took 15 and multiplied it by that value of x, which is now 4, what's 15 times 4?
60.
Very good. It's 60. So at 60 feet, she did that in 4 seconds. We were tied at that point. What if you took x, value of 4, plugged it in here? Use PEMDAS, or the order of operations, which I know you've learned that as well. 10 times 4.
40.
40, good. Add 20.
60.
The algebra is amazing. I love it. Good gravy. Whew.
You know PEMDAS? Please excuse my dear Aunt Sally. It's
Yeah.
also pizza ended my day alone Saturday.
That's kind of sad.
I made it up in 4th grade.
You made that up in 4th grade? That's a little bit sadder than just excusing your dear Aunt Sally. Are you sweating?
No.
Is this how cowboys wipe their brow? This is a great lesson. Thanks so much for joining us.
You're welcome.
There's a little bit of sweat there. Did you have fun?
Mhm.
I had a really good time with you. You're a great guest in our studio. Does this feel like a studio down here?
No.
No?
It's just a camera.
We're literally staring at a camera in our basement. But I hope you guys at home now know a little bit more about points of intersection, POIs, which we call...
Please!
That is correct. Very good, Beth. So, I've been ending these videos, especially when I have a guest, with like a little, not so much a trivia. I'm kind of parched. Are you parched?
Yes.
I feel like I've been on my horse all day, like sucking in the dusty road. It's time for a drink of water.
Coffee.
Well, you got water.
Yeah.
I got coffee. Yeah. You ready? This is almost like cold now. You ready? And swoop. Cheers. Ding. Swoop back. That's good. That's a solid A. That was a really.
Oops, I spilled my water a little.
That's okay. That's a solid A on the swooping ability. But anyways, I've been given like a little trivia. Let's throw a trivia question at him, just to see. That's some. Looks like you've been like mining for coal or something. Let's throw this. Let's do a 2-part question. Okay. So at the bottom of your Google Doc, we're gonna test to see who made it actually to the end of this video. If you did, thumbs up. Good for you. Thanks for joining us for the entirety. But here's your 2 trivia questions. In the spirit of sporting events, like our race that we just had, let's ask them this, and I'll ask you as well.
Okay.
What's your favorite sport to play, and what's your favorite sport to watch? What's your favorite, and maybe they're the same. What's your favorite sport to play? What's your favorite sport to watch? Put that at the bottom of your Google Doc. Big bold letters so I can see it, so I can't miss it. You're not going to get like bonus points for it. We're just kind of like having an exchange because I really can't talk to you guys face to face. This is just a nice way to like share, interact a little bit. So Betsy, I'll turn the question to you. Besides riding old Tot down the dusty roads, what's your favorite sport to watch and what's your favorite sport to play?
I don't really watch sports.
Okay. Honest answer. What's your favorite sport to play?
Kickball.
Kickball. That's a good answer. That's a really good answer. Nice. Oh, what's mine? Thanks for asking, man.
What's yours?
Gosh. That's a good question. I'm going to go favorite sport to play. I really love playing horse out in the back. Not playing with our horse, but playing the game of horse.
We don't even have a horse.
No, we don't. Playing basketball, horse, pig, around the world, whatever. That's so much fun. I really love playing that with you girls. But I think my favorite sport to play, and I have very good memories of playing it with my grandpa. He taught me how to play. Tennis. That's right. I love playing tennis. I love being outside. I love the smell of tennis balls, like a fresh...
And opening them.
Yeah. Yeah, it's a cool sound. But I think my favorite sport to watch, I'm going to have to jump right on your kickball bandwagon in the Western theme here. Jump on the kickball bandwagon. I love watching kickball. It's an exciting sport to watch. Watching you girls play kickball is a highlight of my life. So there's your 2 questions. What's your favorite sport to play? What's your favorite sport to watch? You got any parting remarks, guest?
I don't know what that means.
Anything you want to share with the guest before we leave?
No.
Great job today with the 8th grade algebra.
Thank you.
Yeah, and thanks for joining us.
You're welcome.
Glad you had a great time. As always, guys, be kind to one another, especially your family. I know you're spending lots of time with your family. Huge blessing. I mean, if you look at it in terms of like good quality family time, be kind to one another. Be patient with one another. Again, a lot of time with each other. It's just it calls for a little bit more patience with each other. And above all, please pray. It's the perfect form of peace. Please pray for one another. Please pray for our community, our school, your classmates, your family, your friends, and our world. That everyone gets through this safe and healthy. And again, pray often, and we'll hopefully see you guys face to face real soon. But until then, have a fantastic day.